let's read the question first. So as you can read the question reads a bubble of gas released at the bottom of the lake increases to 8 times its original volume. Okay, so let's understand this particular line first. Okay, let me remove this. Okay, so there is a bubble at the bottom of the lake, and there is that bubble rises up to the surface of the lake. All right, so as the bubble keeps on the volume of the bubble rather keeps on increasing. Why would the bubble increase its volume? Let's understand that phenomena first. So if you look at the question, the bubble is at the bottom of the lake. So at the bottom of the lake the pressure would be really high. So if the pressure is high, the volume of the bubble will be less. Why is that? This is according to Boyle's law. Okay, the reason Boyle's law is applicable because as you see, the bubble at the bottom will keep on rising, and the diameter of the bubble will also keep on becoming bigger and bigger. So the moles of air inside the bubble is constant. So moles is constant. So moles of air inside the bubble is constant. There is no leakage in the bubble. If there is leakage, it will break immediately. All right. So the moles of air inside the bubble is constant. All right. Secondly, temperature is constant. Temperature is constant. We need to, even if it's not true, we need to assume that it is constant in order to solve this question. So temperature is constant, and they have not commented on the temperature, so I'm going to assume that it's constant. Okay, so when moles and temperature both are constant, we can apply Boyle's law in it. What Boyle's law tells you is that at the bottom of the lake, the bubble will be small, and when the bubble will be small, the pressure will be really high, and the volume of the bubble will be less. As the bubble rises to the surface, at the surface you will observe that the pressure of the bubble will decrease and the volume will increase. So at the bottom you will observe that the pressure is higher. Why is the pressure higher at the bottom? Because of the water column. There is water above the bubble, and because of the higher water column above the bubble, the bubble will experience higher pressure. All right. So at the bottom the pressure is high, so automatically the volume will be less. All right. And at the surface, I can tell you, and the surface, the pressure will decrease. The pressure will decrease because the pressure experienced by the bubble at the surface is only atmospheric pressure. Okay, whereas at the bottom the bubble is experiencing atmospheric pressure plus the height of the lake above it. All right, so pressure is low and the volume will be bigger. Okay, so this is what explains the increase in the volume by 8 times. All right, so now they have given you data that atmospheric pressure is equivalent to the pressure exerted by water of 10-meter height. We need to figure out the depth of the lake. Okay, so it's a simple question. So we need to figure out what is the pressure, let's say point A and point B. So pressure at point A will be atmospheric pressure plus the pressure due to the height of the lake. Okay, the pressure at point B will be atmospheric pressure. Now let's figure out volume at point A. Volume at point A will be, if you look carefully, volume at point A would be let's call it V, and volume at point B will be 8 times the volume of the bubble at point A. So it will be around 8V. All right. Now let's select this particular and just move it thoda rightwards, leftwards. Now let's apply Boyle's law. So pressure at point A is atmospheric pressure, which is equal to 10 meter of height of water. So it will be 10 plus the height of water, let's call it h, multiplied by volume. This will be equal to pressure, atmospheric pressure, which is again 10, okay, which is again 10, and Yeah, and multiplied by 8 times v. So we can see that the v will get cancelled out, and it will be 10 plus h equal to 80. So h will be 70 meters. So this is the height of the depth of the lake, or the height of the lake, you can say. Okay, so the answer is 70 meters.